Ratio questions show up in a bunch of different formats on test day because business schools want to see if you can handle this idea. Ratios are important, and as such you get 5 or 6 ratio questions. Some of them are data sufficiency, some of them are problem solves, but they're all built around one core idea, and I will show you that in just a second. The information tells us that we've got a ratio of apples to bananas to cantaloupes in the ratio of 3 to 4 to 5. And then the question asks, well, how many bananas are actually in this bowl? We don't know how many are there, we just know what the relationship is from one type of fruit to another. But you do notice the ratios. And the key to all of these ratio questions, and there'll be about 5 or 6 of them, is that ratios are all about multiples. You keep that in mind and you'll be ready to tackle any ratio question that you see on this exam. What this means is the number of bananas has to be some multiple of 4. We're just not sure which multiple yet, not until we get down to the facts. Fact 1 tells us there are 15 cantaloupes. I'm going to line that up with our ratio for easy reference. Since ratios are multiples, what do you have to do to go from 5 to 15? You have to multiply by 3. And if you multiply one piece by 3, you have to multiply the other pieces by 3. So that means you've got 9 apples and 12 bananas. And thus you've got the question answered. There are 12 bananas in this bowl because of the relationship and the fact that there were 15 cantaloupes to begin with. So fact 1 is sufficient on its own. Real fast, real easy to pick up. You will see something just like this on test day. Fact 2 gets a little wordier, but I'm going to line it up in much the same way that we did fact 1. We're told that the number of cantaloupes minus the number of bananas gives you a difference of 3. Now some of you might see the fast way to do this, but I'm going to show you the little table method so you can use the fast way down the line. Since we're dealing with multiples, the smallest multiple would be 3, 4, 5. But is that a difference of 3? No, that's a difference of 1. Well, that doesn't match, so it's out. The next multiple would be 6, 8, and 10. Is that a difference of 3? No, it's a difference of 2. That doesn't match, so it's out. Remember, if your numbers don't match what the fact told you, you have to chuck it. If we have 9, 12, and 15, that's a difference of 3, and that matches. So we could have 12 bananas. And I want to go one bigger just to see what happens. We could have 12, 16, 20. But that's a difference of 4, and that's too big. That does not match. We don't have to test anything else because it would just get bigger and bigger and bigger. The pattern here tells you that. 1, 2, 3, 4, then it would be 5, 6, 7, and so on. The only way to get a difference of 3 is when it's 9, 12, 15. And that's enough information to answer the question, how many bananas are actually in this bowl? So, fact 2 is sufficient on its own. The final answer is going to be that they are both sufficient. This is a real standard part of the GMAT. You're going to see something just like it. This is one of those questions that just makes me smile. I can pick it up in 30 to 60 seconds, and using this exact method, so can you. It's real easy to grab all these points, and that 700 just gets closer and closer and closer to reality. Commit this to memory. You will see it on the GMAT.